The problem reads a 0.115 kilogram hockey puck moving at 35 meters per second strikes a 0.265 kilogram octopus thrown onto the ice by a hockey fan, which I guess happens someplace. The puck and octopus slide off the ice together. Find their velocity. So I think what you have to assume, so let's given, here's the ice, and here's the hockey puck, and it has a mass of 0.115 kilograms, and it's moving with an initial velocity v that is 35 meters per second. That's really fast. And then it strikes this octopus looking thing. I don't know. I don't think that's where their mouth is, but you know. But anyway, and this I think it's at rest. You're assuming it's at rest. Somebody's thrown it on the floor, it's laying there, gets hit by a hockey puck. The mass of this is 0.265 kilograms. And they move off together. So this is before the collision. So after, they're stuck together. So here's the ice. And here's the octopus kind of wrapped around it or whatever. But it's moving at, it's moving as one thing. V final, with a certain final velocity. And we want to find that final velocity. So let's solve it. Now the principle here is that this is a collision between two objects, and during a collision, if there are no net outside forces acting on your system, and we'll make these two guys our system, that there is no change in momentum overall, so that the initial momentum of my system equals the final momentum of my system. And so well, what is the initial momentum of my system? Well, I look at my before picture, and I say, well, the hockey puck has momentum, it has mass, and it's moving, but the octopus doesn't. It has mass, but it's not moving. And momentum is the product between mass and velocity. So all the initial momentum is in the puck. So that's the mass of the puck, and we'll make this object 1 and this object 2. 1, 2. If you used A and B or you know, puck and you know, O for octopus, I don't care how you label them. M1 V1 initial, and that's all the initial momentum. That's going to be equal to the final momentum of the system. While I look at my after picture, these two objects are now combined into one, so we have to add their masses and then multiply by the final velocity, because they have a common final velocity, because they're stuck together. So this is the final momentum of the system. And now, this is physics right here. After this is just algebra 1. So V final is going to be equal to M1 V1 initial divided by M1 plus M2. So M1 is 0.115 kilograms. V1 initial is 35 meters per second. And then M1 plus M2, well, that's 0.115 kilograms plus 0.265 kilograms. So multiply this times this, well, you get about 4, a little over 4, and you divide that by something that's about 0.3 something, and you get a final velocity when you crunch all that into a calculator that is 10.7. I'm sorry, 10.6. Doesn't really matter. V final is equal to 10.6 meters per second. And that's how fast they move off together. Pretty fast, actually. Any questions? Okay, there will be a collision problem on the final, or not the final, the midterm, I mean. Very similar to this. The exam, unit exam. I'm sorry, went into college mode there for a second.